Then there is another term which is called region growing. So the region growing tool makes it possible to split the segmentation created by thresholding into several objects and remove floating pixels. Okay, you can see that if we are once we have done thresholding, we get the bone structures, say in the pelvic bone, hip joint region. And then if we are interested about femur only, we can apply the region growing tool and filter out the pelvic bone. Okay, you can see here very clearly. We can filter out that if we are interested, or if we are interested in the pelvic bone only, the blue portion, we can actually grow the region, and then that's why it is called region growing. Okay. Now, when we enter one slice, for instance, this is a slice femur bone, we would be interested in detecting the contour of the slice, the boundary of the slice, edge, boundary, or contour of the slice, because that is based on which we can do the geometric reconstruction. We have to define the boundary of the bone. That is most important. So edge or contour of the slice in the CT scan can be detected using the contour detection algorithm. Okay, so there is a contour detection algorithm which is of course based on some scientific criteria, and obviously you can imagine that the contour detection algorithm can be set up in such a way that if where you have the sharp gradient between the pixel gray value, that is where we have a boundary. Okay, so that is not very difficult to make an algorithm, because if you see that at the boundary we have hard cortical bone, and immediately after that we have either soft tissue or water, fat, maybe air sometimes. So there would be always a jump if you try to move. At any point, if you move normally to the curvature, you can actually detect where, at what location there is the sharp gradient that is appearing. That is where the contour ends, or that is where you can define the contour. So like this, you can detect the contour of each and every slice. Okay, you can actually take as many key points defining the contour as you want. Actually, we need that information for reconstruction. So we see the detected outer contour of femur and pelvic bone in two different files. Okay, so one is this femur, the green one, and the pink one is the contour of the pelvic bone in one particular slice. So if we summarize the methods, the segmentation of the image isolates structures of interest. Okay, we can say the segmentation of the image basically is isolating the structure. Okay, then we do the, of course, we do the region growing. Then segmentation, after segmentation and region growing, we go to contour detection, contour extraction. And then after stacking up the slices one after the other, okay, so if I go back, we can stack up the slices like this and then fit a surface to regenerate or reconstruct the solid model of bone based on CT scan values. So we can do a surface fitting and thereby generate a volume. Then we can do, once we have generated a volume, a solid model, we can do all the operations like placement of the implant, all the virtual operations in the computer, guided by, of course, based on surgical techniques. Okay, so this operation requires clinical knowledge, and often it is done in consultation with the orthopedic surgeon. Okay, so after we are satisfied with positioning of the implant, then we can go for finite element meshing. So obviously, you can see that there is, from CAD operations to FEA, there is a transition here. Okay. Just to show you that if we have a, we generally deal with STL files, okay, because that are not too large and easy to handle. So we export STL geometry to ANSYS ICM CFD measure, and there we can actually do these operations. So we do the build topology. These are, commands by which we can actually refine the solid model. Then we can actually, the solid model is ready to be meshed. And then we finish the meshing in ANSYS just to separate the meshing. We have to be careful at the interface. Now, that is for a intact bone, a natural bone. We can actually do the surgery. I would like to show you the surgery. So this is the natural solid model of the natural, the STL file. We import the prosthesis. So we separately generate a prosthesis model, which can be easily generated using SolidWorks or any other software, and then we can import it, the STL file, and then we position it according to suggestions of the orthopedic surgeon, move the implant to the position, then we use the cutter, but actually this is the computational surgery. What is done is just the reverse. In reality, we first chop off the head, then bring the implant, also drill the hole, position everything, then put the implant in position. But here this is computational surgery. Okay, so we bring the cutter and then we cut off the bone. Okay, so Boolean operation: remove femoral head, femur, and implant. Okay, and then the implant is partitioned. Then export it for meshing. To summarize, this is from CT scan image. We are processing the CT scan image and we are employing the geometric reconstruction procedure, okay, to generate the finite element model. On the left, you have the CT scan image of femur. You apply thresholding, region growing, and contour detection one by one. So this is first one on the top. Just let me, more interruption. So this is thresholding, this is region growing, this is contour detection. Okay, so once you have generated the contours, you can stack up the contours. You can see very easily, it is visible, the reconstructed image based on the slices. And when you have connected the slices and fitted the surface over it, you can generate a volume. Okay, but you have to be careful about the accuracy of the reconstructed model. Okay, so you have to be really a little bit careful here that you don't generate too much error, because that error would be magnified in subsequent operations. Now this is the solid model and finite element model of a reconstructed femur from these images. Similar type of operations we actually did for the pelvic bone. So here also CT scan and data of the hip joint. Here you also do the thresholding region growing contour detection, and each slice of the pelvic bone is stacked above one another, and then surface fitted to obtain volume of the pelvic bone, of the hemipelvis. So surface fitting and volume generation, finally meshing of the pelvic bone. You can, by the way, you can also use hyper mesh. Some students in my lab, they are also using hyper mesh to mesh the solid model. But yeah, we have done both. Doesn't make too much of a difference.
내 인생에 다시 꿈을 찾으라고.
What do we do with this?
난 나이라도 어리지. 넌 그 나이 먹고
Okay. That's the important question. Why do we actually take so much of pain in generating a very good quality finite element model? Okay. Here, in one slide, there are two pictures, as you can see. Okay. It's not too old, about 12 years old. This is the picture of a hip resurfacing arthroplasty. Okay. Now, resurfacing is a minimally invasive implantation procedure of the hip, where you can see the prosthesis looks like a mushroom, and we only machine off the articular surface of the hip so as to fit, because as you know, due to degenerative diseases, the femur head, the cartilage and the femur head bones, they are somewhat degenerated. So we actually do resurfacing of the femur head without actually not cutting off, not resecting from the neck. So total hip arthroplasty and hip resurfacing is essentially different. So in case of hip arthroplasty, we would have chopped off from the neck the whole portion and implant, and a full femoral implant would have gone inside. I have shown you the picture. I think you can recollect that. Let me go back. Here. So here you are chopping off from the neck, the upper part. So the proximal part of the femur is mostly gone, and an implant, femoral implant, is inserted and placed in position. But in case of resurfacing, the neck is preserved, only a part of the head is machined, and this mushroom type of implant is fixed. However, the acetabular component remains the same. It is essentially a surface replacement. So in this case, it is both surface replacements on the femur side as well as the pelvic side. Now, what is the problem? The problems have been reported in Journal of Bone and Joint Surgery, American volume. This is metal-on-metal hip resurfacing arthroplasty. A very important observation was reported in 2008 that clinical studies report femoral neck fracture as the most common short-term failure mechanism. Okay? So immediately after surgery, when a patient is returning to normal life, there were reports that there is a femoral neck fracture within a very short time after surgery. Okay? And there has been reports of stress and strain shielding as well as bone remodeling causing implant loosening. Okay? These two reports came up as a recommendation of the consequences of hip resurfacing arthroplasty. Now, we took up this job. We tried to gain an insight into the mechanical causes of this failure. Okay, so we actually built up a model, developed a model of the femur, natural femur as well as implanted femur. So based on CT scan slice, layer reconstruction method. Calibrated the apparent density in terms of CT gray value. Okay, so that you can calibrate based on 2 points. One is just 0 point. The other is the highest point, that is CT gray value of, in your image, the highest point is the CT number of cortical bone, and you know the density of the cortical bone. So therefore, you can have your own calibration equation. When you get the apparent density, you can use the appropriate density modulus power law relationship. So this can actually vary from anatomic locations. If this one is used for the femur, for pelvic bone there is another one. So we get a FE model where each bone material can be assigned individual material properties based on CT gray value. So once we have the finite element model, we can actually map each element back to the CT scan. Okay, and from there we can pick up all the pixels contained in that volume. Okay, average of the pixels that are contained in that, and calculate the apparent density and elastic modulus of that element. So this whole procedure is based on geometry. First comes from the CT scan, layer reconstruction method we apply, and then we get a solid model, then a finite element model. So after getting the location of the element and the volume of the element, we can go back and extract the mechanical properties. Basically, if we get hold of the CT gray value, we are done with it, because the others is mathematical procedure using the equations, appropriate equations, to get hold of apparent density. Once you have the apparent density value, you can relate to elastic modulus, strength, anything. So this was a very important revelation. So in 2010, we could actually publish in the top journal, Journal of Biomechanics. So you can see Paul et al. Paul was my first PhD student, worked in the laboratory, but we came up with some important message that you can see on the right-hand side. It's a long stem, the stem that was used. And if we actually divide it into several regions, 1, 2, 3, 4, 5, 6, 7, 8, we can actually do a stress analysis as well as employ the bone remodeling algorithm. We could see that there was a high strain in the junction of the superior part of the femoral neck. Okay, so around here. So this strain concentration actually propagates later on, and it propagates through a track, and with loading, full loading, this bone is failing here. Okay. Instead, if we were using a shorter stem, this is a design change. If we are using a shorter stem, we are getting much better stress distribution and comparable to more physiological stress distribution. So these sort of things, you can see predicted change in our bone density for short and long stem designs. Okay, using the bone remodeling algorithm, we could see that this is post-operative. That means the starting point. Be it long or be it short, the bone densities are unchanged. But when you use a short stem, you actually get bone apposition here, bone appositions. This is almost normal, but you get more favorable bone density distribution. You can see. Whereas in case of this, you can see bone resorption immediately below the prosthesis. Okay? If you compare the right-hand side, extreme right-hand side figure with the left-hand side figure, post-operative, you can see and compare the changes in bone density distribution. Now, we also carried out experimental investigations. I will dedicate one lecture on that later on, but I would rather stop here because the pelvic bone analysis, I would want to do it separately. So any questions if you have, you can ask me at this point. Just a moment. Yeah, carry on. Hello. Hello.
Yes, sir.
Yeah. So just to show you, MS Sebi replied to your.
Yes, sir. Yes, yes.
Okay, so you're there. Yeah. Okay, so just to show you one example of how powerful is the biomechanical analysis in gaining an insight into the failure mechanisms. Okay, so Shimin et al. Paper, as we had discussed, was from a clinician. Okay, this process is resurfacing, hip resurfacing process. You can get a lot of data, you know. If you just search in the give a hip resurfacing, you can get the implant. But I was working in Southampton during that time, and this there was a project that came up to me to investigate what are the causes, because there was already reports from patients, University Hospital, and also DPU Johnson & Johnson headquarters in Leeds, that they were having this problem. So I started the work there, later carried on in IIT Kharagpur when I returned. But there were many revelations, and for your information, within a very short time, this prosthesis was actually taken off the market, because we published our first paper in 2006. My paper, which is quite cited very well, that was with my colleagues in Southampton. You might find it in clinical biomechanics. But later on, with my PhD students, we extensively looked into different aspects of this promising design, hip resurfacing, which you can understand that it is minimally invasive. It removes minimum amount of bone. Okay, and it's good. It's good for young people who encounter hip replacement surgery, but there were problems associated with the design. So we changed the design from a long stem to a short stem, and now I think the short stem design is already established in the market. Okay, so there are reasons to believe that this biomechanical analysis, if it is done well, can actually come up with many answers, which is not possible if you do a clinical trial. Okay? Anything else? Is it clear to you whatever I presented? Hello?
Yes, sir. Yes, sir.
Yeah. You can also get this lecture in GAN. I think it should be in either day 4 or day 5. Okay. But I will give you a comprehensive idea of what, from the start to the end, how this biomechanical analysis, how powerful it is, how these are being used worldwide, the state-of-the-art techniques. that are being used worldwide for different clinical investigations. Okay.
Hello, sir.
Yes.
Sir, we studied that joints are connected, ligaments, tendons. So
Yeah.
in implant procedure, how ligaments or tendons are connected for actuating the joint motion?
No, no, ligaments, see, ligaments connect bone to bone, right? So
Yes, sir.
ligaments connect bone to bone. So that system is not disturbed. In the last class also there was some question. Mostly that system is not disturbed. The ligament. There are examples when ligaments are sacrificed, particularly in case of a knee. Okay, I have in my house a knee. Just let me just show you. Can you see this, everybody?
Yes, sir.
This is from DPU Johnson & Johnson, okay, where I was a senior research fellow. So this is a implanted knee, and you can see inside here that this is the ligament cannot get in. So this is somewhat, the design is made such a way that the stability is automatically provided by the implant and not by the ligament. In that case, the ligament is sacrificed, because here the knee joint is held together, but not the collateral ligaments on the two sides. Okay, collateral ligaments on the two sides remain intact, but the cruciate ligaments that crisscross inside is sacrificed. So there are designs which.
Sir, is there a revolute joint in that?
No. This is a knee joint, so it is.
No, sir. I mean, is there a revolute joint in the inside of it to aid the folding?
No. There is something I will explain you later. Something like that, a stop type thing. Okay, it cannot go. It cannot move sidewise. Okay, I will show you in the next class more elaborately when we have a little bit more time. Today I'm a little bit in a hurry, so I will explain this whole implant system separately. Okay, so ligaments, tendon is something, it connects muscle to bones, but of course all the muscles are preserved. Okay, so that's the reason a patient needs physiotherapy to reactivate the muscles. Because of the surgery, everything is opened up and then it is stitched back again. Okay, but in specific cases like the knee replacement, the ligaments may be, one or two ligaments may be sacrificed depending on the design. Okay, there are two types of design. One is cruciate ligament preserving, the other is cruciate ligament sacrificing. Okay, so depending, there are clinical criteria based on which a surgeon selects which type of design he will be actually selecting for a particular patient. It is all patient specific. Did you get my answer?
Yes, sir. Thank you.
Okay. So, Sevi, you can continue with some of your clarifications.
Yes, sir. Yes.
I would like to be excused today because I have to. I have some preoccupation. So I'll meet you in the next class on Wednesday. Okay.
Yes, sir. Yes.
We have much more interesting things to follow. So please be tuned in this online class. These are, bread and butter stuff of our laboratory. We have been working more than 15 years and regularly publishing in the top journal. So all the state-of-the-art techniques, research, and development in this subject is IIT Kharagpur based. So we are the leading group in India as far as biomechanics research is concerned. Okay, you can look into my website. You will find a comprehensive idea what has been done over years. Okay, thank you, and we will meet again on Wednesday. So I am leaving the class. Sebi will take over. Okay, Sebi.
Yes, sir. Yes, I'm here.
Thank you. Thank you, everybody.
Okay, sir. Thanks. Hi guys. If you have got any doubt or any clarification to be made, particularly on this project report which you have to submit on 21st, isn't it 21st or 22nd? When is the due date?
22nd.
22nd, sir.
22nd. So 22nd. So basically, you have to. Last time during the exam, I mean the numerical type one, many of the students are not using this. What do you call this? Apps which helps you in scanning the photo. I mean scanning the answer script, and it makes your task easier. So avoid clicking the photos with your camera app and converting it into PDF. Rather than doing that, just use Adobe Scan, or there are apps now which makes things easier for you to scan the answer script and send it. So do that, otherwise it will be really hard for you. Like maybe I'm not sure how many pages the project report will become. How many pages have you written till now? Like anyone? How long is the project
Around
report
10
right now?
pages.
10 pages.
Around
Okay.
but it will go till around 20 because we are currently in the middle of our research.
Okay, fine. So if you are using some data, like uh, I mean, it's up to you whether to use, I mean, whether to mention that table of data in the project report, or just mention that the data has been used from so and so, or something like that. Otherwise, what will happen is, I mean, we know what data you are using. You just have to mention which time instant you are considering to do the inverse dynamics. So rather than like using the same data which you can find in the HIP 98, are you getting me? Like you don't have to try to make the project report big. We won't weigh your project report, okay, based on the size. So it's based on your content. I mean, the content of yourself, not HIP 98 content. We won't look at whether you have copy pasted those tables and all. So basically, the evaluation will be logical. Logically, it will be evaluated depending on how unique it is. So, like many were having this question. I mean, I have written the answer which has been already shown in the slides. I mean, yes, I mean, there are things which are not shown in the slide and discussed in the class. You're getting me? So we are actually looking into that. Like anyone can look into the slide during the exam and just do the same steps and score it. No, so, but if you attend the class, there will be more than what it is being written in the slide. I mean, we can't write everything in the slide. So avoid those kind of queries, because we are actually looking into those who have put effort in listening the class, following up the class. And I actually saw one answer paper in which he has actually considered the inequality constraint, that muscle forces has to be greater than or equal to 0. So I have given maximum mark for that answer to him, because that is also one of the point which I discussed in the class, even though it is not mentioned in the slides. So it's up to you. I mean, you have to listen the class. Otherwise, you can just read the slides, and the project report will be evaluated in the same fashion. I mean, the best project report will get the maximum mark, and in the same order the good and the worst will follow. So try to keep it crisp and clear. I mean, don't just use the same, what you call, tables which you see in the Hip 98, because we know that those table exist. So keep the things to your. You are getting my, you know, like you are understanding, no, what I am trying to convey, isn't it? Hello.
Yes, sir.
Yeah. So
Sir, I have
rather
one
than
question
use,
particularly.
yes, yes.
Sir, when I was writing the review of research papers, so and then when I
Uh-huh.
checked with the one free anti-plagiarism software, so it was showing
Mhm.
around 35 to 40% of plagiarism. However, I have written everything on my own. It's just that
Because you
that
haven't finished the project report, no? Like once you finish the project report, I mean the percentage will reduce, no? Because right now you have just written the literature. I mean, I won't check the plagiarism essay wise. I mean the question wise. I will check it, check the whole content, no? So the percentage will get reduced to less than 20 percentage. What I will check is it should be around, I mean, it should be less than 20 percentage. It should not be like 50, 40, something like that. You get me? Like
uh,
right now, have you finished the project report?
no, sir, only the review part, only the three
Then
review content.
obviously there will be 30 percentage, no? I mean, once you finish the project report, then check it.
And
I
sir, one more
bet
thing.
that it will be. Uh,
Uh, Sir, we don't have any access to the, I mean, anti-plagiarism software. Whatever I have used is only 1,000 words I can check. Okay, so
okay,
we can't.
limits. Uh,
Yes. So could you just provide us the, I mean, some software through which we can actually check how much of our work is coming into what percentage,
I'm
like
not
that?
sure whether you can access
You
Grammarly. I
can
mean,
you can mail ERP and you can get Turnitin.
yeah, Turnitin as well as Grammarly. I mean, I think you can get it. ERP, actually, you don't have to, whether you have to mail or not, I'm not sure, because for PhD scholars, you can directly go to that library website and register. I think even master's
We also
students
have to go
can do it.
to UG also has to go to library site and register.
It's for
Yeah,
everyone.
then you, yeah, so you can go to library site and get the Grammarly or Turnitin. They actually do it really fast. I mean, they do it monthly. Like if you want the license for this month, you have to apply this month, and then for the next month you have to do for again register again. So I think you can just ask your friends or directly go to library KGP. I don't know the entire web address. So library website and just register using your KGP mail ID, and then it's done. Like you can do the plagiarism check. I mean, everyone
Okay,
try
sir.
to do the plagiarism test, okay? Because I won't give a feedback that plagiarism is greater than something or not. I mean, I will just check it. Then if it is more than what I consider as the limit, then I will reduce the mark for sure. And literature review will contain some, I mean, some plagiarism. That is for sure. But don't go with the content of just literature. You will add more content, no? There will be a lot of content after literature review. So the percentage will obviously reduce. So don't worry about that. Like just check it after once you finish the project report. And whenever you write something from some paper or use the same figure of the paper, then try to cite it. Below the image, you can write source. It is also possible. These are actually technical stuff which you should learn through this research oriented course. That's why we are adamant about these particular small details. Any other doubt? Like I actually pointed out how many? One, two. Plagiarism something I have pointed out earlier too. And this thing, like whatever data you find, don't just copy paste. I mean, we won't check the number of pages. Okay, we won't look at the number of pages you are filling. I mean, it should be whatever you, yeah. Hitesh has shared that screenshot, so you can see in that particular block in which it says register your something something. So what are you saying? Yeah.
So if you are taking some data, so is it okay that we just cite the data that we have taken from here and not just put it in our report?
Yeah, you can just write it, no? Like which time instance you are considering. That is fine. I mean, which trial you are considering. That is fine. I don't want to see a lot of tables which has been already put in. I mean, which can be accessed in from the HIP 98. I mean, what is the point? That is waste of space, isn't it? You can just mention the time instance chosen, the trial, the patient, the body weight. Those are the specifics which we look into. You can also look into the research papers related to HIP 98. They won't show the what you call the marker position data and all. I mean, uh, those are provided in the HIP 98. Now they will just mention the data has been collected from HIP 98, the patient name, no patient code, and body weight. That's all. So those are the things. I mean, I will just try to convey it in a similar words. Keep the report unique. Like even if you want to help your friend or other group members, just give them ideas. Whenever someone asks me something in the teams, I just give them idea. I don't give them the direct answer, because if I give them the direct answers, they won't look beyond it. You're getting me? So I should not, I mean, my answer should not confine them to particular search area. That's why I don't give direct answers. I just tell them whether it is possible or not, whether it is there or not. That's it. Any other doubt? I think everyone has started this inverse dynamics thing. I mean, it should not be a big deal, because you have sufficient time. Like 10 days is more than enough. And keep it unique. That's all. Like I will just look into how unique your project report is. I don't want to see tables or images which is already there. Like what is the point? I just want to see how much you have put the effort. I mean, similar way I have corrected your answer scripts. I want to see how unique your answer script is. I mean, you can. I was also a student till the last semester. I know how the online exams goes. So the slides will be open in other tabs. So yeah, we won't put all the information in the slides. We will discuss it in the class. That's why we have classes. So if you try to remember, recollect those information and put it into your answer script, then we will be more convinced, no, like that you have put effort. So that is the thing. Keep the things unique, then you will score uniquely. It will be better or worse. That depends on the quality. So have you got any other thought? I think I have mentioned almost every aspects. Software works. How plagiarism software works, it just looks into the sentence structure actually. That's why I told you that you can paraphrase, then actually you can escape this plagiarism. So if you see something like what do you call some sentence, you can just paraphrase the sentence. Like what do you call Hitesh shared the screenshot of library website. The library website screenshot was shared by Hitesh at 11:50, something like that. Paraphrase the sentence, then you can escape the plagiarism count. So those things actually come with experience. I mean, how to paraphrase things. So those things, changing from one form to another, active form to passive form, or using some other words. So those things actually you will learn. Like you can look into the resources to how to escape plagiarism. Those things, that is also possible.
So means we write the sentences in our own words, but in free software it is still showing plagiarism. Is it search word by word or line by line? I want to ask that.
No, I mean reading a paper and writing it in your words, That's what we want actually. But some sentences, I mean, for example, results, there will be one or two sentences which you have to write in the same fashion. So you have to paraphrase it. That's what I'm talking about. I'm not talking about taking each sentence and paraphrasing it. You're not going to write the same paper. That's what I'm trying to convey. Like some sentences may be important, no, for some papers. That you have to paraphrase. I mean, that's what I'm trying to convey. Our intention is like you should be reading those papers and trying to understand what they have put in the paper and write it in your words. I don't want, I'm not expecting more than 3-4 papers for this particular literature review. I mean, if you can concise, you just write what they have tried to achieve, how they have tried to achieve, what experimental setup, and what results. That's it for each paper. I mean, I think it should not be more than like 3-4 papers in total, the literature review. So you can write. I won't be particular about the English grammar you use, okay? But I will check it. But try to avoid blunders with this English grammar. I mean, in Grammarly also you can check it. That's what I'm saying. Try to get the Grammarly account. Within one day you will get the access. So don't worry about it. Try to do it and correct it before sending it to me. Like if I come across some blunders, like some you are trying to use present tense, past tense in the same sentence, then I will surely cut the marks. I mean, those are epic blunders, na? Using this different tenses in the same sentence. So that's what I am trying to convey. I mean, you can check. I mean, make it perfect for yourself and then send it to me. Then I think you will score good. But to be more particular, the quality will be checked first. Quality, I mean the content quality. Then only I will go to the plagiarism test, then the English grammar, all those other stuffs. I won't look into the aesthetics first. I will just look into the content quality. So avoid the tables, and if you can avoid, just avoid unnecessary figures. I mean, in the previous reports, I used to see a lot of unwanted images. I mean, they just put it to what you call sell the content, but the content actually lies in the uniqueness. I mean, the quality actually lies in the uniqueness. So, is there anything else? Hello. If there is nothing, we can wrap it up. On Wednesday, I'll be talking about bone orthotropy. I'll be discussing with you some previous works, and one of my senior has also worked in bone orthotropy. It will be interesting. Bone orthotropy will be interesting. So just look into the contents related to the elastic constants associated with the anisotropy, orthotropy, transversely isotropy, isotropic materials. Those which are the basics of the topic which we will be discussing. Can anyone tell me how many elastic constants are there for orthotropic material? I'm just curious, I mean, whether you know it or not. Can you hear me? Many? Hitesh, you can type. I think your voice is breaking. I can't hear you. How many?
Independent are there?
Orthotropy has got 9. That is correct. So, yeah, independent elastic constants. Correct. 9. And isotropy has got 2. And anisotropy? Anisotropy, how many?
21.
Yes, 21. Okay. For linearly elastic material. Okay, for linearly elastic only the elastic tensor will be symmetric, otherwise it's not symmetric. So those things are basics. I think you already know. I'll just discuss that over a single slide. So that's it. Then have a nice weekend. Bye.
Thank you, sir.